Alright, in this video we're going to look at a couple of topics. We're going to look at solving two types of application problems. One's called mixture problems and the other's called job problems. And then we'll look at a little bit of a brief, we'll touch on briefly some complex numbers. Okay, so for mixture problems, usually you're mixing two things, whether it's in this case coffee or maybe two different interest rates. You're getting a certain amount of interest. We'll get an example like that. So let's go ahead and take a look at this problem here. It says a coffee distributor needs to mix a Costa Rican blend that normally sells for $11.60 per pound with I think it says it's Terraza, a coffee blend that normally sells for $14.30 per pound. And they would like to create 70 pounds of a coffee that can sell for $13.18 per pound. How many of each kind of coffee should be mixed? And so I'm going to draw a cylinder here to kind of help us out. Okay, and to kind of help organize our information here. So we do have a total pounds. We have total pounds being 70, and we're doing a linear equation in one variable. This can be done with two variables. If you know how to do it with two variables, you can do it that way, but we're going to do it as a one variable. So let's say hypothetically that we know we have 30 in one, then the other one would be 40, so that would add up to 70. And how we get that is 70 minus 30. So if one of them is x, by the same reasoning, the other one would be 70 minus x. Now it doesn't matter here which one is Costa Rican and which one is the Terraza. It doesn't say anything about it. It just says the total amount of coffee we have at the end is going to be 70 pounds. So we'll just go ahead and put one in there. So we'll say the x belongs to the 1160 and the 70 minus x is going to be 14.3. So we're going to get out our mixing cups again to help organize our thoughts. And so inside the cup is going to be the price, and then underneath the cup is going to be the pounds. So we get our price per pound. So we're going to have 1160 and then x, 14.3, 70 minus x, and then the 13.18, and we wanted 70 pounds of that. And so what we're going to do is we're going to find the total price. So if we multiply the price times the number of pounds, that's going to give us our equation. So here we go, price per pound times pounds, price per pound times pounds, equals price per pound times the number of pounds. And that's going to give us the total number of value. So the total money value for the two individuals should equal the final mixture there. So that's our linear equation. We'll have to distribute the 14.3, do a little bit of arithmetic. 11.6x, distribute the 14.3, 1001 minus 14.3x equals 922.6. We'll go ahead and move the 1001 to the right hand side. Underline our like terms, so our like terms combine to negative 2.7x equals negative 78.4. I'm going to go up to the top of the screen there, and all I'm going to do is rewrite it because I'm about out of space, and usually we have some sort of thing blocking the picture here. Okay. So last thing to do here is to divide by negative 2.7. So we'll go ahead and divide both sides by negative 2.7. That's going to tell us x is about 29.04, and that's going to be pounds of the, and here the x represented the Costa Rican blend. And so to find the Terraza, we're going to take the 70, total 70 minus the Costa Rican, and so we get 40.96 pounds of the Terraza coffee. Okay. Now, if you decided that x was going to be the 14.3 and the 70 minus x was the 11.6, you'll still get the same answer. Your x will just represent the Terraza instead. Okay. So you'll have one pretty similar to this on your homework. It's going to work out real similar. It'll probably have different numbers, maybe different types of coffee. Okay, so we're going to look at another type of mixture problem. It's basically the same thing. It's just a different story here. And so I'm going to speed it up a little bit, and then we can read that. All right. So it says a candy distributor needs to mix a 20% fat content chocolate with a 30% fat content chocolate to create 150 kilograms of a 23.3% fat content chocolate. How many kilograms of each kind of chocolate should be used? So this one's pretty similar to the last one. They do tell us the total amount we want at the very end, which is 150 kilograms. So we'll go ahead and put in our cylinder to help with the mixture organization. Okay, so the total amount, or total kilograms, is 150. We can use the same reasoning to kind of figure out how to do the X and then what's the other thing for the two things we're mixing. So let's pick a concrete number like 25. So if we have 25 of one, then the other one would be 150 minus 25, or 125. And if I add those up, that's going to be 150. If we do it generically, if we call one of them X, the other one's going to be 150 minus X by the same reasoning. Here it doesn't matter. One of them's going to be 20%, and then the other one is going to be 30%. Looks kind of like a 38. So one thing to mention, percent means per 100, okay? And so I'm going to write up here in orange how we kind of translate that. So percent means per 100. So 20% means 20 per 100, or 0.2. 30% means 30 per 100, or 0.3. And 23.3% means 23.3 per 100, or 0.233. Okay? And so the quick way of converting from from percent to decimal is you just move the decimal place twice, move the decimal place twice, and move the decimal place twice. Okay? So when we're doing any sort of computation, we could, I guess, technically get away with it here, but it's a good practice to convert into a decimal, because when we say 20%, we don't mean 20, we mean 20 per 100. So it's best to convert that to a decimal. Okay, all right, so let's get out our mixing cups. So our two things for mixing. All right, so we'll put in our percentages as decimals, and then the number of kilograms. So you got your kilograms and percentage. So 0.2x plus 0.3, 150 minus x. So what those two represent is, this represents the amount of fat in the 20%, the amount of fat in the 30%. And that should be equal to the total amount we're mixing together here. Okay, so very similar to the previous one, we'll go ahead and distribute the 0.3, get 45 minus 0.3x, and then 150 times 0.233 is 3495. We're going to go ahead and isolate the x, so we're going to subtract 45 from both sides. So subtract 45 from both sides, and then we'll combine our like terms also. So we got negative 0.1x equals negative 10.05. Let's go ahead and erase our cylinder because we're out of real estate. And we'll rewrite and solve that by divided by negative 0.1. So there it is. And divide by negative 0.1. And so that's going to tell us x is 100.5 kilograms, and x represented the 20% fat content. So to find the 30%, we're going to take the 100.5 away from 150. It gives us 49.5 kilograms of the 30% there. Okay. We're going to look at one more example. I think I have another video on mixture problems, so you can search my YouTube channel for it. I'll see about maybe posting a link to it as well on Blackboard. All right, so the third one is a little bit different. It is a mixture problem, but it's going to involve something called simple interest. And so simple interest is typically a short loan or investment based off of a year. So it's Your interest is equal to your principal times the rate times the time. I stands for the interest earned or the interest owed, depending on if it's a loan or a investment. P is a principal. That's the amount loaned or deposited. That's going to also be your starting amount, whether you're loaning or depositing. R is an interest rate as a decimal. And T is going to be time based off of 1 year. Now, for this particular problem and the ones that you're going to have in the homework, the ones I would ask you on the test, is going to be set up so that time is 1 year. Okay, so we won't bother with the time. Later in the semester, when we start talking about compound interest, then the time might be something a little bit different than just 1. Okay, the interest and the principal should be money values. R's interest rate as a decimal, and T will be 1 for our purposes. So what that does is, for this application or applications of this type, it's going to be I equals PR, and then T would be 1, but PR times 1 is just PR. So interest is equal to principal times the interest rate. Okay, so let's go ahead and write down our problem. And we'll put in our cylinder there. Okay. So it says a combined total of $50,000 is invested in 2 bonds paying 4% and 9% simple interest. The annual interest is $3,700. How much is invested in each? Okay, and so what we have is we got $50,000 to invest into 2 accounts, and so our total invested is $50,000. One of them will be X. One of them will be X. And so, like the previous arguments we had, let's say, for example, we said one of them was $20,000. To find the other one, we would take 50,000 minus 20,000 and get 30,000. Now, because I don't know what it is, one will be X and one will be 50,000 minus X. Same reasoning. Okay, one of them will be the 4% and the other one will be the 9%. Okay, we'll get out our mixing cups. And this one's going to be a little bit different because we don't have a third percentage. We don't have a 3% fat content we want. We don't have a third price per pound. So this one's a little bit different. So we're going to still try to stick with the mixture content, but we're going to look at what the first 2 mixing cups kind of represent. Okay, so I'm going to put stuff in 4% X, 9%. 50,000 minus X, and I'm going to cross out the last one because we don't have some sort of final mixture. So when I do the 4% times X, that's the principal and the interest rate, so interest rate and principal plus interest rate times principal. What that is calculating right there is, this is telling me interest plus interest, right? And that's going to be your total interest. And we know what our total interest is in this problem. It is $3,700. Okay, so it's a little bit different, a little bit tricky. Take a little bit of practice. You get the hang of it. Okay, distribute the 0.09 through. You get 4,500 minus 0.09x equals 3,700. Go ahead and subtract the 4,500 from both sides. Combine your like terms. We got negative 0.05x equals negative 800, and I did migrate to the top because I ran out of space. So we have negative 0.05x equals negative 800. Divide both sides by negative 0.05. Divide by negative 0.05. X is equal to 16,000, and that was at the 4%. So to find the 9%, subtract that from 50,000, and so that's going to tell us we invested 34,000 at the 9% there. Okay. So if you have any problem that you run into like this, they're all going to work out real similarly. So if you see an interest problem like this, you got the video example here. They'll be all very similar. So the next type of problem we're going to look at is what's called a job problem. And it's going to involve a rate and a time. And so, let's say it takes you 2 hours to wash your car, then in 1 hour, you're going to wash presumably 1/2 of your car. So if we do your rate of 1/2 per hour, 1/2 what? 1/2 job per hour. And so that's going to equal 1 job. So we're going to be using the fact that rate times time is equal to 1 job with these particular problems. There is a table that your homework online uses, and so I'm going to try to match what you got going on the homework system. And it does a pretty good job of organizing it. So we're gonna do a table with this. We're gonna go ahead and fast forward a little bit to put some of that information on here. All right, here we go. Okay. All right, so it says one pump can empty a pool in 5 days, whereas a second pump can empty the pool in 13 days. How long will it take the 2 pumps working together to empty the pool? And so you got some sort of table going on here that looks kind of like this. You got work area, time alone, rate alone, time together, and I think the last one is work together. Yeah. Okay. Okay, so we'll go ahead and call it pump 1 and pump 1 and pump 2. So pump 1 time alone is 5 days. Pump 2 is 13. And then the last row is number of jobs, which will be 1 in each case. So we're going to be doing basically just 1 job here. Okay, so if the time is 5, the rate is 1/5. If the time is 13 to complete the job, then the rate is 1/13. They're going to be working together the entire time, so we'll call that T. And so rate times time, 1/5 times T, 1/13 times T is going to equal 1 job. And on that far column on the right, that's actually going to be our equation there. So we have T over 5 plus T over 13, and that's going to be equal to 1. Just like the other ones, what we're going to do is we're going to clear the fraction. So the LCD of 5 and 13 is going to be 65. So what we're going to do is we're going to multiply everything by 65 or 65 over 1, depending on if it's a fraction or not. 5 goes into 65 13 times. 13 goes into 65 5 times. And then 1 times 65 is 65. Combine your like terms. 18t is equal to 65. Divide both sides by 18. T is equal to 65 over 18. Or we can get a decimal approximation of about 3.6. And it is not hours. It should be, what do we got going on here? We got days. So let's go ahead and change this to days. Okay. Okay, so let's go ahead and look at another one. Go ahead and fast forward. Oops, too far. Okay, so it says it takes an older employee 11 hours to shovel snow from a sidewalk, but a younger employee can shovel the same sidewalk in 10 hours. How long will it take them to clear the sidewalk if they work together? And so this one, they set you up with a table. So you got your work area, we got the older and the younger employee. The number of jobs is going to be the 1 for all of them. Time alone, rate alone, time together, and work together. Okay, so the older employee takes 11 hours, the younger takes 10. So the rates will be the reciprocals, 1 over 11 and 1 over 10. Time together is what we're trying to figure out. That's going to be T. Work together, work is rate times time, so 1 over 11 times T, and then 1 over 10 times T. That's your equation. 1 over 11 times T plus 1 over 10 times T equals 1. So that's going to be T over 11 plus T over 10, and that's going to be equal to 1. The least common denominator here is going to be 110, so we're going to multiply everything by 110. or 110 over 1. 11 goes into 110 10 times, 10t, plus 10 goes into 110 11 times, 11t, equals 110. Combine your like terms, 21t is equal to 110, and divide both sides by 21. So your time is equal to 110 over 21, or approximately 5.238 hours. And I think I'm probably being specific like this because the problem I pulled off the homework system wanted 3 decimal places. Okay? So very similar. So if we're doing something like completing a job here, this job would be clearing the sidewalk. The previous one was emptying the pool. Those are kind of our giveaways that it's going to be a job problem. And they'll all have a pretty similar setup. The last one is going to be, we're going to try to make it pretty similar, but it's got something that makes it a little different than the other two. The key is with both 4 and 5 is they're working together the entire time, whereas the last one is a little different. So let's go ahead and get stuff going there. Okay. So it says 2 welders who work at the same rate are welding the girders of a building. After they work together for 13 hours, one of the welders quits. The second welder requires 24 more hours to complete the welds. Find the time it would have taken one of the welders working alone to complete the welds. So we got welder 1, welder 2, number of jobs, same table as before. It's going to be slightly different because of this, the fact that they don't work the entire time together. Okay. So time alone we don't know, but they tell us they work at the same rate. So we're just going to call that T. Number of jobs, it's still going to be one job. Their rate is going to be the reciprocal, so 1 over T and 1 over T. Time together, they work 13 hours together, so we're going to keep going with that. And then work together, 1 over T times 13, 1 over T times 13. And that's not going to quite be one job, okay? So this is a little bit suspect here. And so we have to make a slight modification here. So we're going to still pretty much do the same thing. So there's the 13 over T and then the 13 over T. So that's welder 1, welder 2 working together. Now what we got to do is we got to add in the time or the work done by the welder working alone, which was 24 hours. Okay, and so this is our together, and this is your alone time. So if we put that all together, that gives us the complete one job there of welding those girders. The only denominator here is T, so that's our LCD. LCD is T. So we're going to multiply everything by T or T over 1, depending on if it's a fraction or not. Okay. So you have 13 plus 13 plus 24. That's equal to T. That's not too bad. T is 50 hours. Okay. So that's how long it would take one welder working by themselves to complete the welds. So I think you have 1 or 2 of these in the homework. They're going to be very similar. They're going to work out almost identical to this. Very, very similar structure. Okay. All right. So we're going to change a little bit of gears here. So we've done 2 different types of applications. Now we're going to go into something maybe a little bit less. Well, I don't know what I'm just mumbling to myself. I was going to say a little bit less challenging because it's not the application problems. We're going to look at complex numbers. Okay, so we've talked about them a little bit. Complex number looks like a plus bi, where a and b are real numbers. And then remember, I squared is -1, and then the square root of -1 is I. And in this context, we're going to be using the square root of -1 is I. Okay, so we're going to do a couple examples. I think they're real similar to some of the stuff that we had on the previous video. There's a couple extra ones in there. So we're going to go ahead and simplify. Simplify the funneling. Okay, so negative square root of -36. The negative on the outside, that negative on the outside makes your answer negative. The negative on the inside is going to give us the I. So they give us 2 different things. Negative on the outside makes the answer negative. Negative on the inside, that's going to give us the I. There's the negative on the outside. And then we're going to write it as follows. 36 times negative 1, so we can explicitly see the square root of 36 is 6, and the square root of negative 1 is I. Negative on the outside, and that gives us negative 6i. So that negative on the outside just makes your answer negative. Okay. What about negative square root of 36? The negative on the outside just makes your answer negative. So square root of 36 is 6. So it's negative 6. Okay. How about the square root of 36? That's just 6. How about the square root of negative 36? Well, we can write that as 36 times negative 1. Square root of 36 is 6. Square root of negative 1 is I. Okay, how about 98? Okay, so if we go 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 98 fits here. So we just need to try everything before that, and it's going to end up being 49. 49 times 2 is going to be 98 there. So we're going to write it as follows. It's going to be equal to the square root of 49 times negative 1 and then times 2. And so we can see what all the parts are. The square root of 49 is 7. The square root of negative 1 is I. And we don't know what the square root of 2 is, so sorry, 2, you just got to stay in the square root. And all right, how about negative square root of negative 150? Okay, that negative on the outside right here, that's just going to make the answer negative. The negative in the inside is going to give us an I. Okay, so 150 is 25 times 6. So let's see what we can do with that. 25, and instead of writing the 6, I'm going to put the negative 1 there so we can remind ourselves that, okay, we're going to have an I there. Okay, negative square root of 25 is 5. Square root of negative 1 is I. And we don't know what the square root of 6 is, so we just leave it there. Okay. All right, we're going to look at 2 other examples. One is just a combining like terms type of thing, and then one is where we're going to multiply 2 complex numbers together. So we'll see that a little bit in the homework section, and we'll do a little bit of multiplication of complex numbers in Chapter 5. Okay, oops. Well, there they are, all completed. So let's do a little rewind. All right. So what do we got? 7 minus 8i minus 1 minus 4i. Okay, so 7 minus 8i. And then you can think of this as a negative 1 here, and then you're distributing the negative 1. So that'll be a negative 1 and then a plus 4i. 7 minus 1 is 6. Negative 8i plus 4i is negative 4i. And if we multiply 2 complex numbers, we're going to FOIL. Okay, so 3 times 4 is 12. 3 times 2 is 6 with an I. Negative 4i times 4, negative 16i. Negative 4 times 2i will be negative 8i squared. So nothing different here. Combine your like terms. 12 minus 10i minus 8 times negative 1, because I squared is negative 1. I squared is negative 1. Okay, I squared is negative 1. 12 minus 10i, and then we have double negative, so that makes it a positive 8. So we get 20 minus 10i. Okay. All right, well, that concludes this section. If you're looking for more examples, certainly there might be some examples on the homework. There's certainly examples in the OpenStax textbook, and you can also check out my OpenStax, my YouTube channel. There may be some more video examples. And well, that's it for this one.